Good evening. Tonight we will take notes on notebook paper or scratch paper, whatever kind of paper you have, and I'll tell you what to write down and what problems to do, and then bring your notes for homework points tomorrow and I will check them. So here's our first thing. Right now, this week, we're talking about line of best fit and scatter plots. So please write on your paper as the title, line of best fit. So your title is line of best fit. Make sure your name and your hour on your paper also. The definition for line of best fit is a line on a graph showing the general direction that a group of points seem to be heading. So for this one, this blue line, you do not have to draw this picture. You do not have to draw this picture. Label your paper, write the definition. But this line shows the dots where they're around. If there was some other dots up here and way over here, then there probably wouldn't be a line of best fit. But because those green dots aren't there, we have a pretty strong line. Since this line is going up, you could envision a little man hiking up a hill, and so the slope, the line of best fit, is going up. So this slope or line of best fit is positive because it's growing. If this line of best fit went downhill and the little man was going down, then you would say that the line of best fit is negative. From this slide, please make sure you have your paper labeled and you have the definition. Oops. Remember, you can pause anytime if you need to write something down. All right, here I have runner speed. So speed, feet per second on the bottom on the X, and steps per second on the Y-axis. So when the runner has gone, they can do about 16 feet per second, and that would have them at 3 steps. There is a line of best fit for this. You haven't written anything down yet. Don't write anything down yet. Just listen along. There is a line of best fit. It's drawn. Let's try again. Pretty good. And then it gives an equation. So this is the equation of that line. Tomorrow I might show you how to find the equation on the line with a graphing calculator, but I'm just going to give it to you today. So if I wanted you to predict what would happen at 30, you would plug in 30 for x. So write this on your paper. Y equals 0.10x plus 1.37. Now we're solving for 30. We're guessing what will happen at 30. So where the x is, you'll plug in a 30. So on a calculator or use Google or something, or do it by hand, your choice, figure out what it would be when x is 30. So you'll do 0.1 times 30 plus 1.37. Bring that answer tomorrow. All right, this is our last problem. A scientist wonders, don't write anything down yet, if you can predict a person's weight at 30 years based on the person's weight at 1 year. She uses some medical files to collect the following data. So weight at 1 year is 21 and weight at 30 years is 124. So then, like, this tiny baby was 15 and later was 122. So the lower it was, the lower it is. Well, let's see if there's any weird ones. This baby was 21, but later was 130, and 130 is one of the highest numbers. Here's what I want you to do for this problem. I want you to look at all of these numbers, and I want you to make a graph. So you'll need a graph like this, your x-axis, put a little x over there, back. Your x-axis will go here. So you'll need 0 to, it looks like 25 might be the biggest. And then over here, you might want to count by 20s or something, and you'll need to go 20 all the way to maybe 130 or 140, and then plot different points. So your last homework problem is, you can write these numbers down if you want, you don't have to, but you need to draw a graph, have a title, an axis, X and Y, intervals, and labels. Have a good night, and I'll see you tomorrow.